Good evening, class. I hope you all are doing well. Today
Good
is
evening.
Thursday, 11/19. How are you guys doing?
Doing good. Thank you for asking.
Thank you so much for responding. Thank you. Today we're going to cover object-oriented programming. And I believe next week, due to the Thanksgiving, we're all having holidays. So most likely the class is because the school is closed. We are not going to have a class on Thursday, and then we just resume a week after that one. So week of 13, which is today, we're going to discuss object-oriented programming with chapter 14, but I will be covering chapter 13 as the last chapter, and I just jump into chapter 14 because object-oriented programming is a paradigm that we need to cover a little bit more than chapter 13. In chapter 13, we will be covering it, and also you have an assignment for object-oriented programming due next week. It's not going to be due on Thursday, but it's going to be the weekend. So you have until the 28th, I believe. I will show you that date on that one, which is this assignment. Let me just go down here. Um, so when we go through chapter 14 for the object-oriented programming, we will cover the four paradigms of object-oriented programming, which are encapsulation, abstraction, or polymorphism and inheritance. Those ones we will be discussing in details and give you more examples as we go through them. But object-oriented programming is not something new to you. You must have been doing programming in Python, which is both function programming, as you know, you have been doing it now, and also the object-oriented aspect of Python has both a functionality for function programming as well as object-oriented programming. And we have been doing objects all along this semester. So it's not something new, but you have been doing it maybe in your C class or I'm sorry, C++ class or Java class or some Swift programming, some other programming languages that you have taken, you might be doing that one. So it's not something new to you, but we will be discussing them. Let me just go to this week 13. And right here, as you can see, there's a assignment chapter 14, which is due on November 28th. And November 28th is not next Thursday, but it's either Saturday or Sunday. It is Sunday, actually, Saturday, actually. So at 11:59 p.m. on Saturday, it is due. You have a little bit more time. And it's not hard. Once you understand the concept and terminologies and watch these videos that are available, you can see I have some videos as well as some topics that you could do when we go through the agenda. Each one of these ones, I'm showing you examples of what an object is, what a class is, what a method is, all of that one we will discuss tonight. And then you should be able to read chapter 14 of your textbook and understand all the terminologies and go through some video examples here. And then there's some video examples here for object-oriented, for class inheritance, variables, class method and static method, inheritance, creating a subclass, how you do that one, and what if the subclass inherit from the superclass, how you do the syntax, all of that one will be explained tonight. And also it is explained on the textbook as well as these videos. So I encourage you to watch these videos to understand them better and go through them. But chapter 13, which is mostly similar to what we covered for chapter 12, which was kind of like URL lab and request and XML, JSON, those kind of web programming, whether it was CGI programming or URL lab or request, it's a continuation of chapter 12, basically. That's why I postponed it, because on chapter 12, we covered network programming, which was socket programming, CGI programming, and URL request, URL lab, and URL lab dot request, and all the other ones. A beautiful soup, and then XML, HTML, and then chapter 13, which is again using web services. Then some of the other concepts that we did not discuss, like service-oriented architecture, SOA. How do you use it? Like SOA is a good example. For example, when you work on an airline, right? When you not work on an airline, when you use a website that is booking airline tickets, as soon as you go to the website to just book your airline ticket, it also give you options to book other services. That's what service-oriented architecture. That website, it is allowing you to go to connect to other services. In the old days of e-commerce, they called those ones business-to-business e-commerce kind of things. So one business through XML would make connections there through this. Now, and instead of using either XML or JSON, these SOA calls are happening through APIs, and then it's happening basically through these calls, and then the request through SOA is going to multiple services. So it could connect to a hotel, it could connect to a car company to book you a car for traveling from the airport to your hotel, and then book you on a hotel, how long you stay, all that thing could be just within one service. You go initially with one service, and then it calls the other ones. And then some other example of JSON and Twitters and other ones are explained on chapter 13. We can cover that one next week with XML and all that things. But even if we don't cover it, it's just the option of these ones are similar to the same URL lab, XML. These are just another kind of mechanism that you use it. But object-oriented programming, which is this chapter, you can see that on the chapter 14, I also have a lot of videos available here for reference. And then programming examples, they are here. And then some PDF files, videos, the part 1, part 2, all of those ones are available for you to understand them. So without further ado, if you have any further question or any question, please go ahead, ask the question. Otherwise, I'm going to open up the agenda for today, and we go with the overview of the Python object-oriented program first. And you're welcome to ask anytime if you have any question.
Professor, I have a question.
Go ahead, please.
So we've been doing object-oriented programming, and I'm personally only familiar with that type of programming. How is it different from procedural programming?
Okay, so look at the variables that you do. Let me just open up Python here. Actually, I'm going to just give you an example with this two windows open up here. Let me resize these ones so I could move them up and down easily. And that's a very, very good question. So at the very beginning of the semester, when we were talking about, we said that Python support both object-oriented programming as well as functional programming. All the programming languages, whether you start learning Pascal, Ada, Fortran, C, or some other programming languages, or even like PL SQL, procedure language as SQL, they did some computation in the usage of something called a function. So in mathematics, when you want to calculate, you say x is equal 2 times something, or x is equal, y is equal x to the power of 2. For every value of x, you have the square of, for every value of x that you get the square root of that one as y. Then that function is going to calculate that formula. So that function has to return a value for y for every value that we gave x. If x is -3, y is 9, because x to the power of 2. And if x is 3, y is still 9, because of the minus and plus does not make any difference when you multiply it by itself. So if, for example, you have x plus y, and then x plus y is equal x plus z, let's say. Y is equal, like you have something like this. Y is equal x plus z, then or x plus 5, whatever the number you have, plus some other number, and then times another variable, which is y itself, or times 2, and then divided by, let's say, 10, whatever number you have, or divided by another variable. These variables, when you do this one, and these are like a function y depends on these variables. So these variables that you declare, whether they have a value that is already calculated, or you're going to determine the value of these unknown variables at some point in your computation, all of this formula or expression has to have a value at the end based on what is the value of x, y, and n. So when you do in a function programming or procedure, these variables, they have no attributes and no methods associated to it, in a way that you can consider each one of them as its own object. What I mean is by object is an object has certain attributes, certain properties, and then certain methods. So the attribute or properties are, for example, a car has names. A car has a model, a color, a shape, a number of wheels, and everything. And then the methods, a car starts, a car stops, the car runs, and the car brakes. Those are the methods. If the object is a human, the human could read, write, talk, walk. All of those are methods. But a human has certain height, certain weight, certain age. Those are certain color of skin. Those ones are attributes or properties of it. So when you're doing a function programming, you're working on an aspect that it is much, much harder to work with 1,000 different parameters and 1,000 different variables. Because those variables, if you just have to define a class of type animals, and animals, you could just, for each of them, when you do a variable, say, for example, on a variable, so you say cat is equal, and then say cat dot, let's say name is equal my cat, and then you do those kind of things, and then name is equal something, age is equal something. So every attribute that you go for an object, that could go in a procedure or function, could go really, really hard, and it's maintenance wise, it's going to make your life really, really hard, because the attributes and the methods that could apply, that could go dynamically. So in a function programming, when you do it, let's say I'm right here, let's say I go, say Python, and inside Python I say a name is equal Wahid. So now I have, if I say type of name, it says as a class a string. That means that this string is the object in this case is name. So even though this is a variable that is there, because Python allow you to do certain things with an object, this type of object name is right now, if I do a dir of a name, you could see that all these methods and attributes or properties that I can check on is already available on it. So there's like, for example, name.title is give me the title of that person, and then a name.upper method will just change the contents of that string to something like, for example, let's say I say name is Wahid, and I say name.title is going to return that title there, but then a name.upper will just convert it to uppercase, name.lower will change it to lowercase. These are the methods that you can do with a string. So the object in this case is a string, but the method that you can apply to them are all these things that are available within that object. But because this is not a class object, certain method that you have on a data type that are class type, you cannot just manipulate certain attributes that are not existed for it. So if I have x is equal 1, and I say type of x, now again, this x is an integer of type, a class integer, right? So then I could say dir of x. You could see that these are the methods that are available in the attribute that are available. So when I'm just doing this, later on, I'm going to show you this example. Let's say, as an example, I will show you a clear screen. Okay. Okay, so I'm going to do a clear screen and then do pet.py. So this file, if I do a more on pet.py, you can see, for example, the difference is that when I'm declaring a variable in this, it's each attribute and name on the variable that you do it within a variable declaration of regular, not regular, of procedure programming or functional programming. These variables are not having any object in a way that you can control it. And unless the programming language is like Python, that it supports both object-oriented as well as functional. So if you do this thing with name on C programming or Pascal or Ada, these methods that are with the string will not be available unless you write one for them. Every one of them you write for it. So when you do object-oriented, by default, the standard library for a string, it has certain method that it's already written for it. Then you can add on your own function, say, I want to handle this also. Here, as an example, if you define a class, object class, and you say pet is a class, but then notice that this, which is called a constructor, double underscore or dunder method. So this one has about three properties or attributes: the name, the age, the color. When you're using this, by default, as soon as you call the pet class, you're defining that one, automatically instantiate this pet. So if you say cat is a pet, and then automatically these attributes will be available for it. And if this is a class, the concept of encapsulation is one of the paradigm of object-oriented programming. Encapsulation meaning that you create an object and you put it into a capsule. Encapsulation is saying that you have that object some properties and some methods. Here are the properties of a pet that automatically every pet can just instantiate and could have a name, could have an age, and could have a color. If you want to add another attribute, you can add on to it. The instantiation automatically will just have another variable here. And then the method with pet, what can you do with pet? And it's like display the name of the pet, says what is my name, what is my age. So these are the method. These are the method of this class called pet. When you do this method, as you can see, the word self is used for each of the methods within the class. The self means it points to the object itself. So when I create a pet later on like this object cat, it instantiated the class cat with the name symbol and the age and then the color. So imagine when I do 1,000 or 1 million objects, I could just read this data from a list or from another file, and I just could instantiate as many as I want. But if you have to do this one in functional programming, this is going to be so tedious, so many error prone, so many mistakes, because a lot of these attributes, they could just have indices that are numbers, and people cannot keep track of them. But with this object, you can add on to the properties, you can remove it, you can do manipulation by just having those one of those four paradigms, which is, for example, right here. You see, I'm creating another class called cat, but of inherited from pet class. By doing inheritance, which is one of the paradigm of object-oriented programming. This one, for example, right now, cat and dog, they both inherit from a superclass called pet, or from the parent class called pet. What is inherited is that all these methods and attributes that are defined on the superclass, automatically the dog will inherit. So, and a dog will have a dog.name will automatically have something. Dog.age will automatically have age. Dog.color would have automatically this. But then there's other properties of programming on object-oriented programming called data abstraction. Data abstraction or data hiding. So you're doing this in order to just have a layer of abstraction. For example, if you look at your remote controller, the remote controller, when you look at the remote controller, is a bunch of buttons. All you do is, or look at the calculator, all you see is add, plus, minus, multiply, a function, a subroot, and square root of something, or something to the power of something, or sine or cosine. All of those functions, the data, the abstract layer is in the front end as the interface, but the actual functionality is on the background. So you will not see the details and the data hiding part of it. And class is a good example of it. So when you declare object, for example, here, notice that this one is a good example of polymorphisms aspect of object-oriented programming. Polymorphism means multiple form. So the speak, which is a method, could take multiple form. In function programming, you cannot do that one. Function programming, you create a function called speak, and then that the speak has to say exactly this word. But this word could be dependent on the object that you create. So instead of saying bark, you could say, maybe if the object is cat, it could say meow, and if the object is dog, then it barks. Or the object is lion, it roars, or something. So those object polymorphism, meaning multiple forms. In a way, like in a calculator, you could say, I could find a function to do multiple operator overloading. Operating overloading is another aspect of object-oriented programming that, for example, sometimes you pass in within the print statement a statement to multiplies, like you could say print 5 times 5, and that will return 22, and now I could do add, so the operator, they could take different forms. This the same function of print it could have parameters. Based on these parameters, it could have a different output depending on what you want to do with it. So that is like, for example, let's say I do this and I say print this 5 times, then you could just see that it is happening. And if you put a space here, obviously, you get 5 of those ones next to each other. But the fact that these operations that are happening, you could just use the print method differently, or taking multiple forms. So you could do that and then addition of something like that, but that's a string. So in that case, it does not make any difference. So it's going to be 2.5. 2.5 is not going to be a right calculator, right? So and if you want to do that one, that's a different thing. So you just have to say, let's say I divide by 5, that is still not going to return because two object, one type of string and the other one is integer. So you cannot print that one. In order to do something like that, you could either convert this one to a string. It doesn't matter what it is, so it would be 1. And then let's see if we could just get that one first to a 1 first. Yeah, a 1, and then times another number. So you could say that this 1 is going to be printed 5 times. And if I do the same thing repeatedly, it just grows there. But that's just printing that string 1 15 times. It's almost like saying that just go ahead, print something of this. That is there. So the data type is on the multiplication is there. But if you're looking at NumPy object, then you can just do a different strategies of just creating these values based on certain methods that are available to you. Coming back to the object-oriented programming, your question was, what is the difference between functional programming and object-oriented programming? The good news is Python allow you to do both. So when you're using Python, you're already using object-oriented programming already. Like I was giving you that example of this. So every object that you declare, whether it's a list that you say x is equal, let's say x for xn, range of 10. Let's say we do that, and then x is, sorry, lowercase x. Somehow it, I pressed the wrong button. Type x, and you can see that this is a list, but type x, and then dir of list, dir of x, and then you can see the methods that are available. So x.append will just append something. X.count will just look at the count. So x.count, and if you say count the number 1, how many are there? It's 0, but this case I could do this and it's going to say 1. And if there's multiple of them, then let's say do I x.insert, and then we could just insert and then number 1 again. So insert requires another position argument where you want to insert it. I want to insert it on the first position, position 0. Now if I do x.count of 1, is going to say 1, and then that insert actually it did it as a integer. So I want to do that one again, and then now do the count is going to show 2. The reason is that this is a string, and I wanted an integer. So this one and this one is going to be duplicated there. And if you just convert it with getting rid of the duplicate now, let's say I called my set is equal set of x. And now notice the difference between this is my set is a list, I'm sorry, is a set, and then dir of X is a list. Notice the number of functions that are available. So with my set, not having the duplicate, but it's a set, and X is a list, which is having duplicate. So object-oriented programming give you a lot of features that are not available on procedure language programming as well as functional programming. Procedure language programming and functional programming is used interchangeably. So in any programming language that they use, whether you use PL SQL, that they use the word procedure, procedure, and they say procedure and then procedure name, whatever is here, name one, and then start the argument and then have some parameters and finish it, or you use function like JavaScript, Java, C, C++. A lot of programming languages, they use function. And then function name, and then parameters. You could do that one. And then on programming like Java and C++, you have a start and then an end close. And then here you have the block of the code. What you do is scanf, printf, whatever you want to do. Those string copy, anything that you do manipulation, define an array or structure or union or class, you could do that one. But function programming is also the word function in Bash scripting, like Perl programming, they could use it. Python, they use def for defining a function. So when you define a function, that function could be part of class. Like here, we are defining these functions that are part of a class, but they still use the def function. But then these are methods, and instead of calling it a function, they're called a method. And then when they're used within a function programming, it's called function. So in Python, if you don't have the word class, and then it doesn't have the parameter self, then that's a regular function. And if you see the first parameter as self or a class, then it's either a method of a class or a method of a class method. So let me just go back to our documentation here and then define these terminologies, and then it's going to be more clear because I went through jumping back and forth to answer that question. But I think it will be more clear once you understand what's an object, what's a method, what's the properties, what is inheritance, what is encapsulation. Those kind of terminologies are more important. Does that answer your question?
Yeah, it does.
Okay.
It sounds, yeah, thank you.
Thank you so much. I sometimes explain too much and not to just say we know we have to use the time efficiently no matter how the question is, but each question when we go through it in a way it is just going to hit some part of some other question that is going to come later. So I want to clarify the whole concept in one shot, and if we can do that, that would be great. Here we're talking about 4 paradigms. In object-oriented programming, whether you use Python, Java, C, C++, Swift, any programming language that you can name it, that are object-oriented programming, these 4 paradigms are being used. So these 4 paradigms are very, very important. And then the first one, it says abstraction and data hiding. By creating a class, when you say a class, a pet, you're doing abstraction data typing, right? You're just basically call it a class with a template as name pet. At this time, you don't know the detail of how the person is going to implement this class. It's just a blueprint. We look at it as a pet, and then pet has certain properties. Those properties is pet name, pet age, pet color. Those are coming in the picture once we define an object of type pet. which we call it, okay, instantiated, or create an object of that type of class. So if the class is called pet, every pet that you instantiate could have certain properties, which is the name, color, age, and other properties, like, for example, size, the number of legs, and then the method that that pet could do. For the methods or the attribute, not the attribute or properties, the methods or the functionality that a pet or that object could perform. For example, a pet could speak or make sounds. The sounds, if they make the pet object is a cat, it makes the sound of meow. If the pet object is a dog, it makes a bark. And if the pet is a bird, which is different type of species, you could say it depend on your definition of what animals or what class that you define. But each one of them, they could have certain properties and certain methods with it. So the class itself is a very good example of data hiding by just giving a name, say auto. At this time, you did not say what type of auto you have instantiated, whether it's a BMW, it's Mercedes, a Ford, Tesla, Toyota, whatever the type of car, you have not defined it. So all you're saying that I have an auto class auto, and then there are certain attributes or properties to that object. And then those attributes could be the color, the shape, the ear, the model, the engine size, all of those ones, the number of tires, the number of seats, everything determines what type of auto or car we're dealing. Whether it's a van or it's a four-wheel drive, those kind of things are the attributes. But then what you can do with a car could start the engine, a car could stop the engine, or could break into issues and you have to repair them, could have an accident, God forbid, all those kind of things, or the method that could happen. So a status of a car, whether it's parked or it's running, those are the methods that you could just check for the properties of the car, the attribute. If the car is parked, then now car.park is equal true. Now those attributes are associated for one car versus another car, you could check it. And then the idea of encapsulation is putting these type of object called a car, like a BMW or a car, Mercedes or Tesla or Toyota or Ford or any type of car that you put, Chevy, whatever model that you can think of it, that class of object has already certain attributes and certain properties. You put them into a capsule called that auto, class auto. And then by instantiating it, now you can just assign certain attributes and certain methods with it. And inheritance, for example, look at, for example, a class called employee. A class employee, every employee has a name, ID, employee ID, a salary, a job title, everything. So when you create a class employee, maybe you could create a subclass called part-time employee. So like a adjunct faculty, I teach part-time, I could be a part-time teacher, and then I could be inheriting certain attributes and properties from a super class called employee or full-time that maybe certain methods within my class is just different. For example, I could only teach 2 courses maximum compared to a person that could teach more than 10 courses or more than 5 courses that they are full-time, depending on the semester. So the fact that we all are employee, we all inherit from the superclass employee ID, employee name, employee salary, employee title. But then certain classes that I have may not be created on the superclass. So then I could just redefine those methods. For example, say I could only teach in the after hours or on the weekend. So those methods are more kind of towards the subclass that is there. But certain property I could inherit from the parent class and do that. Same thing with, for example, with human. As an example, a class human, we're all human. But then there are subhumans, sub different subclasses. Some of them are teachers, some of them are students, some of them are employees, some of them are children, some of them are adult. So all different type of categories. And if we look at it in the parent class or super class, we're all called human because we all inherit same thing, that we all have a name, we have a height, weight, certain body shape and certain things. But then the subclass of students, for example, students could go to class full-time or part-time, or a teacher could teach full-time or part-time, or employee could work full-time or part-time, or one person's voice is different than another one person's speed of running is different than other ones. So those attribute and property for each of the subclass that we talk are different. So that's what inheritance, sometimes they inherit from the parent class, but they also have modifiable method and attributes that are not defined in the superclass. Polymorphism is the idea of multiple form. Poly means multiple, morphism means form. So multiple form, I give you an example of the print function. Another example of polymorphism, the method speak or make sounds. So when your object is cat, it makes the sound meow, and the object is dog, it makes the sound bark. So the idea of functional programming, those ones are a little bit more tedious to modify and configure it and update it on the fly versus object-oriented. There's a lot of different examples. You might have seen it on real life. Those situation happens at all times. What you will learn. So this is basically on the module overview of Python object-oriented. We need to understand these four paradigms, what they are used, because whether you use C++ or Java or any other programming language, you will be understanding abstract data type. Abstract data type or data hiding is basically a class, a blueprint. A class is a template. You just give it a name and then the rest of the data is hidden through the object attributes and through the object method. Later on, depending on how many attribute and method you define, that detail is data hiding, they call it. And then we discuss encapsulation, inheritance, polymorphism as well. So let me go back here and go to the next page of this. Do you have any other question? Okay, let me just go back to that page, and it is spinning here. Oh, that's slow. So let's see if this page is the same. So agenda for the first lecture, I just had this one. I covered it last time. I just continued that using that one because I defined a lot of the terminologies here. So in this one, we're going to discuss these terminologies. We already talked about what is object-oriented programming, and Python is supporting both functional and object-oriented programming. With object-oriented programming, something is called a class. So the first thing that you define is a class. You are doing the encapsulation part of the object-oriented paradigm. By defining a class using saying class, like if you see here, I just say class and then parrot. So this, by defining this class called parrot, automatically I'm doing a data abstraction. This is the parrot is the blueprint, the name that has this kind of definition. So this parrot is defined with attribute of class attribute of species is bird. So this is a class attribute. A class attribute is just basically you can define it inside the class. This is similar to a class method that you have here, like some of these other method that you have here, class method. And then this is just an instance of the object because we're using self. And then right here, we're already using the class parrot, which was instantiated by using this dunder method. And then the self and name and age. Self is just the object itself. Every time you use a function that uses the double underscore init, which is called the dunder method or the magic method or the init with a double underscore method, is the constructor in C or C++. So you're just using this one to instantiate an object. And the object, for example, here is blue is one object, woo is another object, my parrot is another object, my P1 is another object. You could just instantiate any object by giving the class name and then with the properties that are there. Notice we are not putting the word self because that's assumed, but the name and age that are defined has to be given. So when you say the parameter blue right here will come into this parameter because we are passing it right here on as a second position argument, and then self.name is going to point to blue, and then self.age is going to point to 10, and then the same thing with woo and 15. So this will create two objects, and then this one will create the third object. And then notice that the third object has the name as talking parrot. So then if we have a object of a method to say something with it, then it has to be added to this list of objects within this class. Then you're going to just say speak or make sounds, def make sounds, and then inside there you could say what the object could say. Then my parrot dot speak automatically would say talking parrot. So you could just do that one. But right now we're using this example that is using is all these examples are using the old style of calling. This is still good, but when we do this kind of statement with print statement, we're using the format like blue.name is going to print blue.h there. But then what you want to do is write a function inside the class to return name or get name or return get age or set age, set name. So instead of just doing it with each property with this, all you have to do is say blue.set name automatically will set the name to blue, and then blue.set age automatically set the age to 10. So a class in this case is a blueprint of kind of like a template. An object is an instance of that class. So in this example, as you can see, these are object. Blue is object, blue is an object, my parrot is an object. Once you instantiate these objects with this type of class, these automatically inherit these attributes. So dot names have a kind of a value, dot age is having a value, and so on. And then object instantiation comes in as a result of class name called the class. And notice the class name has uppercase P with the syntax. So every time you define a class, the word the class starts here, and then you have a uppercase P. Now for parrot, for pet, you have a uppercase. For animal, would be uppercase A. And then you could write here within the left parenthesis, right parenthesis, you could put that to left parenthesis, right parenthesis still would work. That is a short forms by saying parrot. Remember the list when you say x is equal 5. Let me just do this quickly. Python 3. So if I say x is equal this list, and then or I say x is equal 5 comma 10, the 2 in my list, sorry, I have to x is equal. So if I do x is equal, now I get 5 and 10 as that, and then I could say for I and x like this, and say print I. So I could do that one and get the 2 values, or I could say for this and then do that. Sorry. And then this would just say start to end and then say print I. That would still do the same thing, disregard to how I used it here and how I used it here, because within this bracket is there. So when you say class pet, you could do this, and then you could say for spaces and then say pass. This one automatically now you define a type of class a pet. So if I just say type pet, and then it is a type of class pet, at this time I don't have any instantiation like I showed you earlier. I have not defined anything. I have not have any instance attribute, or I do not have any class attribute. I don't have any methods defined, but I just say this. I could also do this class pet, and I could use the 2 brackets here. That would also do the same thing, pass. So now type pet. So what I'm showing you here, the syntax wise, both of them are the same there in regard to that. So if I look at the type of directory of pet, what does this class do? These are by default or attributes that are available within that class. Whether I want to do some comparison or get the dictionaries or get the directory of it or anything, documentation, to compare it, less than a lot of those ones. And the net method is by default available for every class. So object and then attribute and properties. Let me go back here and then exit out of this and then do this. So as you can see, clear the screen and then do this and then move this one a little bit here and resize this one a little bit. Okay, so you can see the attribute properties like these are the properties of an object that you can do, and this is how you assign them inside this init constructor to create them. So as soon as you use the parrot, automatically it will just have those methods available. And then sometimes a constructor or distractor, a constructor creates an object and then distractor is going to delete it. On some programming languages or C++ and other ones, sometimes you have to use a distractor to get rid of an object. And here you can also do like Python 3, you could say, for example, class pet, and then let's say you say pass, and then get out here, type pet, and then I could say delete pet. So this one automatically now is gone. I don't have it. And I could just also create a class called x is equal 5, type of x is equal this, and I could delete that x object. By deleting that x object, x is no longer pointing to any area in memory with the variable 5, automatically you are just getting rid of it. So that's a distractor kind of things that you could do. But there's other ways you can do it within Python or other programming language. We're not gonna discuss that one because automatically when you exit out of this, the object, if I create an object called x is equal 5, and then I say x here, automatically when I exit out here, now I go back, that object is not defined. So automatically Python context manager is going to take over and is gonna do something called garbage collector. In programming languages like Java, you have used the term garbage collector, which is in the memory, whatever was not used recently or last used, maybe that is no longer needed to be used. And the garbage collector and the programming language is going to take care of it. And then on Java and C, C++ is something called system.gc. So system.garbage collector function calls will do that function of garbage cleaning. Sometimes it is the context manager of the programming language like Java does it. Sometimes the user, the developer calls the manually the system.gc function to do that one. And then in Python, you either do the del or you just let it be done by the distractor. When the object loses the scope of it, it is also destroyed. So the object is no longer available. So we talked about method. What are the methods here? And like here, I could say, exit out of here, and then let's see pet.py, cat -n pet.py. So you can see pet.py, we're talking about methods. Methods are what an object can do. For example, the cat method here has a speak language, a speak method. And then the language that it talks, it just says meow. And then a method called getName. So whatever is the name, because it inherits the name attributes from the superclass called pet, automatically you return self.name, it will just say cat. If it's a cat, it just says maybe Samba. Like here you see the cat is there and then it says Samba. And if it's a dog, it says Parkan. If it's fish, it says tuna. If it's dog one, Jasmine. So you could just see depend on the name of the class. But these are the methods that are defined. And then you can have on each type of class different methods that it could have. Like this one has getName as well as setName. So you can set the name of the class. These are, as you can see, for every object, they have a self on it. So that's the methods that are defined within a class. Class methods. And then we talk about superclass. Superclass in this case, if you could see the pet class, the pet is the superclass because all the other subclass or dog and cat, they inherit from the superclass. So the child class is the attributes that are defined. Maybe one function or one attribute is different, but they already inherit from the superclass. And then there's some kind of data manipulation that within a class you can do to just have the access modifier. The access modifier in C and C++ or Java, when you use them, they call it public, protected, and private. So something that is in the class that is public, it's available to everyone. Something that is protected, it's meaning that it's open to class and a subclass of that class. But something that is private, it's only available to the class itself. For example, when you define a social security, maybe it's only available to you and your family members, or maybe just to yourself. So if it is just to yourself, that is private. But if it's a phone number or maybe a bank account that you share with your family and your children and your brothers and sisters, or anything that you share that could be protected within your family or within your friends, you could share your email address and this and that. But there are certain things that you want to just make it widely open, your address or something, and it's on yellow pages, so it's open in public. If it is your address is hidden from public, then obviously you are not advertising it in yellow pages, and that's some sort of protection there. You maybe charge certain fees for doing so by certain companies that they don't advertise it. But a lot of those data hiding sometimes is really hard because a lot of security is involved with it. And then when you do it with class, because of data hiding and abstraction and all these four paradigms, sometimes it makes it so easy within object-oriented program to control your data and not allow certain hackers or certain other classes to just come and read the same data that you're hiding it from them. In functional programming, sometimes it's not easy. You either give it or don't give it. It's either one way or another one. With object-oriented programming, you could say certain attributes could have it based on their other attributes of what is the relationship of that two objects interacting with each other. And then you can pass on certain attributes to it or certain methods to do that. Derived class or classes that are from the parent class, they derive some attributes. So for example, when you use a class dog here, is derived from the pet class, which means that the dog class automatically has all these methods that were defined within the superclass called pet, and all these attributes are already available. So they are automatically assumed derived from. For example, a part-time employee is having certain attribute like name, title, job, salary, and all those things, or derived from employee class, which is called superclass or parent class, or the super or parent class is for the main superclass. When it is child class or subclass, is derived from the superclass or parent class. In constructor, we use the init method, the double underscore init method, and then constructor, you can see that whenever you do instantiate an object based on these properties, that object will be created. So now later on, when I'm using these names, automatically it creates those instance. So we did talk about object-oriented programming versus functional programming, and the concept of functional or procedure programming language. There was something on the programming language called remote procedure calls. Remote, anything that is remote between a client server, you're making a call to the remote computer or remote process. That's a remote procedure calls. This P stands for procedure or function, and then call is just to call it, meaning that you're passing some parameter of function 1 to be computed on computer 1. And then that result comes into computer 2. That is a remote procedure calls. And this is a function programming or remote procedure calls. That term, remote procedure calls in object-oriented programming like Java, C++, Python, when you're doing it, and that same term changed to RMI. R for remote, again, remote is remote. Procedure becomes method. Method, and then call is invoked. I for invoked. So they use a different terminology to make a difference between function programming and versus object-oriented programming. Object-oriented programming has its own terminology. When I was doing my master's degree on computer science, we had to take high-level object-oriented programming, in which each object has certain kind of the book, I think it was called Rambo's, the name of it in terms of object-oriented. This is back in 1995, 96. But when we were doing this one, at that time, we were just using these objects has a, like for example, is like X, N, or Y, that one, you have that attribute if it is in Y. Remember that when we were doing a string manipulation, sometimes say if string 1 is in line or in this variable there, then you do these things. If it is not in, all is not in, and all of those ones are attributes of or methods of object-oriented that you could do comparison. So these terminologies are a lot of them, and we just are covering some of them here. But when you take a Python programming language with object-oriented class, maybe advanced class, or maybe a C, C++, you will cover a lot of these ones again in details, and your instructor could help you understand it much better than I do. But sometimes maybe just covering the same thing that I already covered, and might be called intermediate or advanced, because some of the terminology is the same thing, whether you talk about it in the introduction class or advanced or intermediate. The object, I have listened to some videos, people say this is advanced Python or something. They don't even discuss some of the paradigms correctly, or sometimes, but there are some good videos as well. So I'm not gonna discredit anybody, but I'm just going to give all of those people that they're training on the internet with YouTube a big thumbs up, that they are doing a great job, and the more they do, the more people are going to be knowledgeable about the same thing. So we talk about the 4 features here already, and then the class method and a static method, I will also explain that one when we come to an example. It is too hard to explain just by giving a name of what this two are. You have to see the actual examples. And even with these other ones that we want, if you just say data hiding is hiding the data or using a class, then it is not clear until you just give a pet class or a car class or some examples there. Python object-oriented example. So a Python string is an object-oriented attribute, and it has certain method. We talked about integer, class, tuples. All of these are objects that you can say when you instantiate a type of a class tuple, then that object has certain attributes and certain properties, or if it is a data dictionary, certain attributes, certain classes. Let's see. Class demo super class pet. So we did talk about the super class pet here that is open. Instantiation, class declaration, instance attributes, method invocation. So all of this, I just went through them. Do you have any question on this that I just went through them? Or I need to go in more detail on this? You're good? Okay. So this one, you can see this example here also. Let's just see if on this example, init self name color. So this class pet, when you define a class, you say pet is the name, and this is encapsulation, or a template called a pet, a class called pet. And then this is the initialization method, which is a constructor, call it on other programming languages. And then in Python also is called a double underscore, or dunder method. It takes a self as an instance variable name, and then the name, and then the age, the color. And these are the three attributes in this case you have. You could say self.name is equal name, self.age is equal age. And notice that these names, the way you define these one, these could be anything. If you say name here, you don't have to say name is like self.name is this. You could just say n and then n here. That's fine, as long as you pass the argument with the first argument having a name, automatically similar to a function programming, that takes control of it when you call it. And here display self dot. So the display method, notice it does not have a color, it does not have an age, it does not have a name. And if you say, well, it is going to call it, how does it know? Because it's part of this initialization. So when you create an object of called pet, of type pet class, automatically the name will be available because of that pet. When we instantiate it, somewhere on the bottom here, like right here, cat, symbol, tree, and orange, this one is automatically, the name is already automatically instantiated with that, and tree is, and the age, and the color is orange. That's how, and that will be there. And then the get name, again, self.name is passed on and returns the, don't know what to say. The speak language, for example, you could just say speak the language, but if the object, you can do a comparison. You could say if the object is dog, say certain things. If the object is cat, do certain object, and so on. And then right here, then a class dog itself is a subclass of that. And then a subclass of that, meaning that dog could speak, and then the speak of dog in this case is barking. And then the name, again, return the name, and then set name returns the name of the dog object. And cat does not have a set name, so automatically has two methods. So this method, for example, is one method that is defined on the cat, on the dog, but not in the cat. So this is a little bit kind of like a method that has its own method. I'm sorry, a class or subclass that has its own method that maybe is not available within the cat class. Until you add that method, the cat class could not just work on this cat class. But then if you have that method is public, available to the subclass, and cat inherits that one, then they could use it. But in this case, if this method is used rather than, which one was it? Set name. Rather than defining within the subclass, if this is kind of needed, it should be defined in the superclass. That way, each method could inherit that one automatically. So here is the definition, then it just does dog.display. So as you can see, the object name dot. The dot properties of the object-oriented is very important. Everything that you create an object dot method or an object dot property will be there. So look at that dog1 dot name as equally also. And then if you just want to give a different name, obviously, you say dog1.name is equal some other name. But this name doesn't have to be defined within that superclass there. You can create another one, dog1.address. You could just on the fly with object-oriented that you say, as soon as you say dot address, that dot address has to be added to the list of attributes of that object there. As you can see here, if I go to Python and then I say, let's say x is equal 5, okay, x is equal, let me just do here, say class human. So I could say class human and then say pass. And then now I say type of class, type of human. It is a class, but then this time if I say human, it doesn't do anything. It just says this is a human of type, a main object of class, which is available for me. But then if I say human1 is equal human, if I just do that one, now type of human1, h1 is an instance of that class human, okay? So at this time, I could have certain property for that one. So h1.name is equal Wahid. And then notice that at this time, automatically I introduce a name attribute. And so a type of, if I say h1.name, it is gonna just give me that attribute. And then if I just say right now, say h1.title is not having anything. But if I say h1.title is equal, and then I say Instructor is there, and then h1.favorite sport, let's say is soccer. So these attributes automatically, if I say type of h1 is there, and then now dir of h1, with that h1 object, I have these attributes that are associated. Right now, I have not defined anything with as a method there, because if I was doing any method with it, I had to do within this class there. Because I said pass, I said later on I'll define it, but because I'm inside the Python interactive, I cannot just go and modify this class again unless I start all over with the same thing. So the way you do that one is just say class human pass, and then write a init method here, and then go on, and then all of a sudden, when you write a method, say get name or set name like we did in the pet, you could do those method, and then the method automatically set the variable to that. So you don't have to do it in the procedure language kind of things. You just call in, for example, say h1 is equal human. I just should have defined it uppercase h, right? Because that was human. So let's just redefine this class called class human, and then I'm going to say, for example, 1, 2, 3, 4, and say def double underscore init double underscore, and then here I'm going to say self, and then say name comma title comma favorite sport. So if you do this right now, I'm just creating this def method, so I have to go for indentation 1, 2, 3, 4. So here I have to say, for example, self.name is equal name, and then go the same thing with self.title is equal title, and then self.favorite sport, self.favorite favorite sport is equal favorite sport. I make sure I don't have a typo with those words. Unfortunately, I did not add on any method here. I could have just defined one method, say add to it or something. But remember that H1, if I just delete H1 now and then just go, H1 doesn't exist. Now I could say H1 is, instead of saying H1.name is this and that, I could say H1 is equal human, and then just create a human called Wahid name, and then title is instructor, and then favorite sport is soccer. So you could do that one, and then human 2 is, let's say we call it Nora, and then we say Nora is programmer, we call it programmer, or Python programmer, we call it. And then favorite sport is swimming, basketball. What is your favorite sport, Nora?
Volleyball.
Volleyball. Volleyball. That's a good sport. I used to play. Love it. So let's do one more, H3. And we call this one Travis. Travis, and then also programmer. Two student or two people could have this one. And what's your favorite sport, Travis? I'm not sure. I think Travis is my Saturday class. Sorry about that. So let's call it John. We call John here. John is there. John, what's your favorite sport? John Paulo? Okay, let me see if he put on something on chat. Basketball. Thank you. Basketball. So let's go with those, and then we say H1. Now you can see if I say print H1, it's gonna just say that's the type of the H1 is basically is one type of object, right? Object of that class, instance of that class. So if I say print H1.name, it will print that one, H1 title, it will print that one in H1 favorite sport. Same thing with the 2. Two is, I'm sorry, 2, the object, and the other one, and then with H2 title is there, same thing with 3. So 3, so 1 was there, we created 1. Oh, I overrode 2 with 2 again. So let me just do the 2 again, because when you just define this H2 twice, it just overrode Nora's information with John. So if I just want to do Nora back as H3, then it will just create an instance type H3 of Nora, and then print, if I say h3.name, comma h3.title, and then h3 favorite sport, all of them you could print it in one shot, and then this becomes a tuple itself. So if I just say print that and then give me the type of that one, it is going to say this one is a string type. So this one actually type requires that as an attribute. Let me see if I yeah, that is one here, and then that's the second one. So in this case, it doesn't take this one because it is just saying that you have argument 2 must be tuple. So we could do this one if we want to print it as tuple. Oh, tuple. We have to do this to say tuple like that. Convert it to a tuple and then print the type of it. And let's see if we do. And now this would be a tuple. Otherwise, it is. Let's see if it does return a tuple that way. I want to do this one again, the print statement. What was the print statement right here? This one was printing this one, and then type of that. Let's see if that would give me any type to see. Yeah, the print statement, it cannot just be as an argument, but we could pass it on to a variable, then print that variable. So this would not work, but you could do this and say that print statement here. This one is printing that variable. Sorry, let me just take this one out. So what? Okay, sorry about that. Let me correct that one. Take this one out. Okay, so this one prints that information. You can print this one to a called T1 is equal, and let's see if it invalid syntax. So this is passed on as a print statement, but that print statement is not going to assign to a variable because it is part of a print statement to print it something else. So in this case, it will not do this, but let's see if we could do something like this. Remember the type of slicing versus just the word here that I'm looking for is not slicing, it's the opposite of slicing, is putting multiple variable into one kind of environment variable. So in this case, it will have that one, and type of T1, it is going to say tuple. But this is packing and unpacking. So by doing this, you're packing 3 variables output into one variable. So this is called packing. And then unpacking is when you just do this. If you say x is equal y comma z is equal T1. Now x is having that value, y is having that value, and z is having that value. That's unpacking. So the opposite of packing is unpacking. By doing this, we packed all these variables into a tuple, and then we defined a tuple here. And then by doing the opposite, assign the tuple to 3 variables, x, y, and z, we did that one. And also, I showed you last time with packing, you could just say x and a star here, a star y, meaning that sorry, a y star, meaning that let's see what invalid syntax, x comma y, T1. Okay, T1 is actually T1 is actually not a variable there, but let me show you the variable. This is just one set. So in order to unset this one, we have to define it to a different variable. So we already defined x, y, and z. So now if I say a comma star b is equal x, y, and z, let's see. This one is b star. Okay, the x comma yz comma here, and balance syntax. Let's call this one 2 comma 3. Story and balance syntax. Oh, this one has to be like this, and then that would do it. But then if I want to just so A, B, C, A as that one, B as that one, C as that one. So now if I want to just assign A to 1 and 1 to A and B to 2 and 3, I could do asterisk. Why is it giving star B? It's not giving it invalid syntax. So we have to look at this example. Somewhere I'm either putting an extra comma or not defining it properly. Let's see if I could put them into tuples and then B star. No, it's not getting it. Let me just look at up something quickly. I forgot the actual syntax on this one. Python packing, unpacking, arguments. Let's see, packing, unpacking arguments. We did this one with less than tuples, but it's the star thing that this is my list, so this is, we already know that part. And so the arguments, those ones will work on this function, D star. That's for the keyword arguments. Keyword arguments, we know that. Let's see. This is not a good example. So I think I might have an example on my own examples here. Let me see what this. So I could come in here. This is what I like about Linux or Unix. So you come here and you say, I'm looking for something with the word packing and unpacking. And so let's say I don't know what chapter we used on that one. Most likely it's either chapter 7 or chapter 8 or something on the string we might have done, or some previous chapters. So I could do a find dot minus name star. This means find me everything with the extension of .py as an example. And then at the same time, if I'm looking for some string, grep minus I, remember the general regular expression parsing grep command? We could just say, show me anything with the word packing or unpacking. So I could say, just look for the packing string that it has that string in it. And then this will search with all files that are with that name. And then I forgot the minus exec here, meaning that run this command first, and then find all the files with .py extension, then execute this grep command, and the contents of them look for the pack string word. So that is doing a grep regular expression. And you can see the name of the functions that are there. Because I did a minus I, automatically it shows me even the line that I have the word packing and unpacking. So and instead of doing this one, I'm going to do a minus L here. Minus L means show me the name of the file also. And instead of just showing me the content of it that has those ones, it says that, okay, I used this one on tuple, and then also on chapter 12. So I'm going to go to chapter 10. And then VI on tuple 2.py. Let's say, look at that one first. And then let's get rid of those control M characters. They're annoying to look at it. Control M. Okay, so packing and unpacking, you can see here my tuple here. This is the word that are those variables. We are putting it into one variable, and then here we're unpacking this to ABC. We did go through this. This is the example I was looking for: A comma star B, and I used the star B. For some reason it was not recognizing it. So my tuple in this case is assigned these variables. And then when you do that one, it let's say why it didn't do it. So I'm going to do the same thing, quit out of here, and then clear the screen, and then cat minus n, my, what is the name? Star.py, cat minus name, tuple. So clear the screen, followed by cat minus n, tuple 2.py. So tuple 2.py. So this one is giving this example. If I just say Python 3, and then I say tuple 1 is equal, and then say 3 comma 4 comma 5 comma dog, doesn't matter what we define, we say that, and then now say A comma star B is equal, and then we say T1. That worked. I don't know what I was typing earlier. Somewhere here, it was not. It was saying star B was, the equal sign was not coming up. Somewhere here. Let's see what I was typing. Maybe I was not paying attention to what I was typing here. Yeah, X comma Y T1, and T1 was a tuple. Oh, in this case, maybe it was not a tuple. It was actually, because we say type is tuple. So it had those variables, and then X comma Y star should have worked. This should have worked. The syntax was correct, but it says standard in line 1. Maybe this basketball is there. So let's see what is happening here. I want to just see the same thing here. Now A is okay, B is okay, because as I said, everything B after that one is defined. So you could say A comma B comma C comma star C is equal T1. Now we have A is 3. So T1 is this, A is 3, B is 4, C is everything else, 5 and dog. So we can see that this become a list. But let's see why our original example did not work when we had this example. I'm curious. So T1, this did not work either. 1, 2, 3. Oh, this 1, 2, 3 is not actually a tuple. It is just some variables. So when you do this, X comma Y, star Y is equal 1, 2, 3. That's why. This one, X is there, Y is there, but because we define it as a tuple, it defines it. So this automatically becomes a tuple. If I just put the word tuple here, is the same. So tuple there, and then I have to define this, and then now X is there and Y is there. So the only difference between that one the left parenthesis, when we define it as tuple, it wasn't defined. If you do it by just by doing this one, is automatically does it okay too. So if I just define, say, dog here, that would also work. X is there and Y is everything else, because Y is pointing to that structure. And if you do define this as packing it, so I call it T1, now type of T1 is automatically a tuple. That is, T1 is having the entire thing as tuple. And then I could say A comma star B is equal T1, it would work. A is pointing the first one, B is pointing to everything else. That was the confusion. For some reason, maybe I had a typo somewhere there, or initially I was using it like a variable that was not having the parentheses. And I don't see that parenthesis was missing. That was the confusing part of it. Like here, this should have not complained. A comma star B is equal 1, 2, 3. Unless I have an extra space that it doesn't cause, that should not cause a problem. And then right here, the same thing, it worked. Okay, so let's go to the next topic here. It's 840, Python script and a pet example. So on the pet example, it prints out the output that I'm Parkan and I'm 5 years old age and my color is white. So all those options are coming as a result, and then the name of the instance of the object are Parkan, Simba, and Tuna, and Bark and Memo, and Tuna don't know how to speak, or the methods values. The attributes are those names there. So let's go to the next one of the same example for the agenda. Let's see what we have here. The agenda will cover the following. So this else finally demo was covered on the previous chapter when we were doing this one. And then Python debugger, I have not covered this one. And I think it is good, maybe I could, after the break, I could show you a demo of Python debugger module to do this. And this is not necessary for object-oriented, but any Python function or object-oriented programming, when you do, sometimes you want to debug your code certain ways. And it's good to know the Python debugger module is available. The Python syntax -d, by default, it goes to a debugger. And then if you want to load the Python debugger PDB, and then we will walk you through that one as well here. And the same stuff that we already covered here, or just repeated, just as an instance. And then here, the class method pet is there, because some of them I just covered on one day, and then those are repeated actually. So nothing here new, let's just see what's the next one. And then okay, so this one is Python object-oriented programming, chapter 14. If you just go through this, each one of these videos, you should be looking at it. But let me go back to the main page of the module.